Excellent. So we're now live. So I would just like to start off by thanking everyone for coming and also give a little bit of an introduction, both to myself and Oxygen Digital firstly, and then I'll hand over to Boyan to start the panel session. So my name's Laura. I am the marketing executive for Oxygen Digital. We specialize in building AI and data science teams all over Europe and in the US as well. I'd just like to give a brief overview of Livestorm for those of you who haven't used it before. So just to let you know, we do have a panel on the right-hand side where you can pop things in the chat. You can ask us some questions. If you upvote the question, then that means that it kind of has a little bit of a higher priority for us, so we'll have a look at that sooner. You'll have the option to answer some polls as well. And if we do have any links that are mentioned while we are kind of talking, I'll make sure I pop them, or they are put in the chat, but we'll also send around an email afterwards. Anything that is mentioned here and the event in total will be recorded, and you'll get a recording sent to you straight away via email, but we'll also pop this on YouTube for you to have a look at a later date. If you do have any problems, please feel free to just pop something in the chat and I'll be there to answer any questions for you. If you do have any questions for me regarding Oxygen Digital, please let me know. I'll pop my email address in the chat as well. And of course, if you'd like to participate in an event in the future, then also do let me know. But for now, I will pass over to Boyan to kickstart our event, and I will be in the background if you need me. Thank you.
All right. First, thanks for everyone for joining. I mean, I personally am joining from Berlin. I heard from Laura that we have people from around the world, so I hope everybody has like a nice morning, evening. Here it is evening right now, I think, for most of us here. But yeah, thanks for joining. Maybe first I'll give a few words about myself. I'm Boyan. I spent most of so I have a bioinformatics background, and this is when I started kind of to dive deep into data science quite a long time ago. After this, I spent most of my career in small startups, learned all kinds of things, how companies work, how companies fail. After this, I became a consultant, so more into data strategy, and this is what I'm doing right now. I work between business and technology, so the topic that we have today is very, very interesting, very relevant to me. And so I'm looking forward to our panel of experts to see if we can shed some light on how to do project management for data. But perhaps now maybe we can start with Deena. Why don't you introduce yourself?
Thank you, Boyan. Actually, we have somehow similar backgrounds. So I started working in data science in 2010, which means that that's over 10 years already. My initial field of study was applying machine learning to cancer, so cancer informatics, which is similar to what you've mentioned, bioinformatics. After that, I moved to Germany to study and then started an industrial career. So instead of academia and research, I focused on the commercial application of data science and artificial intelligence, which is very exciting. And during those years, I've also worked in several fields like automated control, finance, marketing, sales, HR, and lots of different fields as well, because I was supporting not only the product development of the companies, but also the internal business processes. So it has been definitely a blast to learn a lot, almost in every field possible, which is one of the best things in this field. Yeah, and I'm originally from Egypt, Cairo, living in Germany now for more than 9 years, but still I never cease to complain about the weather, so it's too cold today in Germany.
Yeah.
And that's the brief intro.
All right. So talking about weather, I think that's a nice segue to Filip, because he's in a sunnier place, I think.
Yes, definitely. I actually can compare between Germany and here. Definitely more sunny and warmer. At least these days, my colleagues there are not having the best weather. I don't know, Deena, but here in Barcelona is very nice. I can mention a little bit about it, but so let me be brief first, saying thank you for the invitation. It's a pleasure to be here today and to participate in this talk. I'm Filippo Mazza. As you can hear from my accent, I'm actually Italian, but I'm living now in Barcelona, having been worked in Germany, France, and other parts of Europe across my career in data science. What I'm doing now is mostly leading data science and machine learning projects within cross-functional teams on the entire span of the business activities we have here at Hewlett-Packard. In the marketplace analytics team mostly, and my passion is designing and implement AI solutions for production. I'm a researcher in data science originally. I had my PhD in France in École Centrale, where I was focusing on machine learning and mostly crowdsourcing for image assessment of portraits. And then I moved into, so I've been teaching for a while in the university. Then I moved to industry, where I was putting this in actual practice, mostly for understanding human behavior and to actually extract information from data. That was my passion, which brought me then later in Huawei in Germany, in the research center of Munich. That's why I was saying the weather, I know it. But definitely then, so I was mostly in the cybersecurity part to understand the behavior of users in corporate networks. And now, the weather brought me to a sunnier place, as I said, but definitely working always in machine learning with Hewlett-Packard for other purposes related to data projects, as you mentioned.
Excellent. Okay. Thanks, Filippo, for this. Igor, why don't you go next?
Sure. Somehow I noticed I've become an old timer because I first started applying math to data somewhere around 98. Initially in nonprofit in Ghana, and then in the UK and the US as well, but also a little startup doing a first round early recommendations engine. And then went on for 10 years in investment banks, quant, data architect, occasional trader. But then the whole big corporate thing got a bit too much for me. So now I'm doing smaller firms. Currently heading up machine learning in Wise, which is really fun because it's still small enough to be informal and chilled out, and not quite as full of processes and rules. But at the same time, it's big enough to have scale, and scale is fun.
Yeah.
And so I get to play with all sorts of things from all sorts of domains, from FinCrime to marketing to treasury, which are all very, very different. And both building up a team and playing hands-on. So, and my secret hobby is getting excuses to use some really weird math and actually make it do useful stuff. Currently playing with mutual information bottlenecks for customer behavior. Whether it will work, who knows?
Excellent. Okay. Thanks for this, Igor. And last but not least, we have Misha.
Yeah. Hi. Right. My name is Misha Panchenko. I'm originally from Ukraine, but I grew up in Germany in the north. And then I moved to Munich, where I stayed almost against my will. So my background is in physics and math. I did masters in those two disciplines, and then did a PhD in theoretical physics. And then I decided not to stay in academia, and completely switched fields to machine learning and AI, where then I worked in the Munich, like middle-sized company in their AI department as an architect for machine learning, learning all kinds of stuff about pipelines and like good code surrounding data, leading some teams. And then 1.5 years ago, I switched to applied AI to have a like more diverse set of projects to work on, where I'm mainly I'm in an intermediate role between the researcher and engineer. So I'm more on the hands-on side of guiding projects. I'm usually in the role of a tech lead or something like that. But sometimes in a more, I find that the boundaries are blurry between tech lead and actual high-level project management, at least in some cases.
Exactly. Okay, excellent. I think after those introductions, I think it should be clear that all of us have quite different backgrounds, really bigger companies, smaller companies, tiny companies. All of us have different roles. And I think hopefully we have different perspectives on what we're about to discuss. So now maybe I can spend like a few minutes to explain what we want to discuss. what is actually project management for data. So actually here I'll be using Miro, which is one of our favorite tools as consultants to work on such problems and to ideate and plan things. And normally when I attack a topic like this, I think about the negative, because I think it's easy to say, yeah, project management is very important, everybody imagines how it looks like when it works well. But let's perhaps start with the horror stories first. And this is something which I call the implementation maze. And many of us, I assume, have been in a situation where we're leading a data team, and then we have the business unit often coming to us with some kind of problem statement. Let's do data science for X, and X could be logistics, it could be pharma, it could be more like customer e-commerce type of environment. But pretty much we as data leads, this is often all that we have, unfortunately. And then with that information, we have the task to go ahead and start to implement data projects, to create products, and all of this. So I have split this maze into several different tracks, because the key thing in project management is people. And as we know, we have all of those different roles. Even here in this panel, we have different roles. And maybe a typical data project you could argue that it would include a business owner. That could be also a client, whether internal or external. We have the data scientist, that would have been myself some time ago. That would be also like a data engineer. And we have a data analyst. And you can imagine at the start of so from left to right, we have time. And the first thing that many of us, especially data scientists, do, where's the data? I can't work, please. Like, what's going on? The project has started. I'm already 1 week inside of it, but I haven't seen even like anything from data. And who do we talk about this? So we start to search for the data engineer, one of the most underappreciated job titles, but that changes, I think, a lot. And we ask them, hello, my friend, where's the data? And at the same time, we're not the only ones on the project. We have a data analyst, and that person perhaps doesn't need the same type of data, maybe not a programmatic access to it. Maybe they need some kind of a more like a graphical tool to look at the data, something like Power BI. And they are complaining more about data access. And you can see the red arrows that I have drawn here. They indicate giving stressing somebody. So pretty much at that point of the project, we have the data scientist and data analyst, asking the data engineer, where is the data? Let's say the data engineer is very capable, everything well, and at some point, the data scientist comes back with the Jupyter notebook and says, hello, yeah, here's my Jupyter notebook. Yeah, please deploy, see you sometime next project. And of course, this is where things start to become very ugly. And we haven't even reached the end of this process where we start to think about deployment and all of this. All of this time, the project gets delayed. All of this time, the project gets delayed because the data engineer, instead of working on their thing, the data scientist, instead of working on the data analyst, instead of making dashboards, everybody waits for something. And the business owner, of course, at some point will start to ask questions. The project has been progressing for some time. Where is the progress? What do we have? And this person will hear all kinds of answers, but nothing satisfactory. So this is what we often have, unfortunately. And my argument towards this is that this is the root cause of bad project management in data. And this is a topic of our discussion today. How can we do a better job so this doesn't happen? And how can we avoid such problems? And perhaps one small thing before I finish this introduction is from already people can bookmark this resource. It's an excellent book from O'Reilly called Practical Data Ops. And here you can see a visualization between two work modes. So one is actually working, where the people are doing work. And in the other one, people are waiting, so nothing is actually happening. And this is focused on data professionals. And often you see that there's some kind of issues like data access, IT resource provisioning, software installation. These are times when we, the technical people, be a bit bottlenecked. So this is another way to visualize how much of the time actually is lost in inefficiency. And I would argue, again, this is another angle to look at bad project management. And perhaps now we can kick off the panel, maybe with my first question. Who of you would like to share a story of bad project management or project management go wrong? And what is kind of the issues that you have seen on your jobs?
I could start.
Yes, please, Misha. Yeah.
Because I have some horror stories. I just have to be careful not to reveal too much. But my horror stories, I mean, I think you're very right, Boyan, in the sense that providing the data can be a real pain for the engineers, and which is not unhappy. But I will go one step further. I think sometimes the customer, I mean, I will call it customer, but it can be internal or whatever, right? It can be the business owner, just it's easier for me. Sometimes I think as a general in almost all of my projects, the customer didn't really understand what they ordered. So they had no clear idea of how to evaluate whether what they received was good or not, and did not communicate it. And an extreme case where this happened was following, where we had a customer asking us to build an extremely ambitious project related to video classification, which is difficult, right? But they didn't have any data on it. Okay, so we said we would work on a public data set as a proof of concept, as a proof of concept that what they wanted could be done and could be deployed to their infrastructure, which was specific and it had to be done live, it had to be fast, and part of it had to be saved to a database in order to permit training. Actually, the proof of concept would allow them to collect data. And we explained over and over again that this is extremely ambitious, it is very difficult, it will cost you money and it will cost you time, because you will actually need to collect data and label data in order to make any progress. And then you will retrain, and then this will permit you labeling and saving data even more. And then the customer said, okay, this is all fine. And we made like an initial POC for a rather very conservative sum of money for like 200,000. Okay, that was our minimal offer in order to get it started on the public data set.
Yeah.
And then what went really wrong is that they lied to us. They said, yeah, we want it like this. We're going to accept your offer, but we're going to split it into parts for purely bureaucratic reasons. So we're going to give you 50,000 and then the rest, but you should develop as if you're developing for 200,000.
Yeah.
Which means we are focusing on like building a framework, building a cleaner code that you would use later on, instead of just pushing through and making whatever is necessary in order to prove that it works. Whatever it means to them. In reality, their plan was, I guess they thought they were smart. I mean, their plan was like, we're going to invest 50,000, see how it looks, and then either keep investing or not. And then they shot themselves in the foot, because then they threw away 50,000.
Exactly.
And then also they shot us in the foot, because we did actually, we improved state of the art on the data set.
Yeah.
So we worked our asses off and went over budget, and said we're going to invest more work because we see a future in that project. But the way they evaluated it was that they took a home video with a camera somewhere, mimicking whatever scenario they had in mind, sent it to us one day in advance in a completely different resolution. They censored out some blocks, so they were like black stuff. I mean, the evaluation scenario was ridiculously far off of the training scenario, and they never cared. So essentially, their evaluation scenario was a coin toss, and then they compared it with somebody else, who probably trained on 3 classes. They probably trained a binary classifier. We trained a multiple class classifier. And then it failed. And
maybe I can summarize this. This is a great thing, and I think what we can do is like listening to this story, we can take like a specific cluster of issues, and I think this specifically is like the one of bad requirements. So when the data team receives a task, and it's not defined well. So then this is a recipe for disaster. So we can put it in that cluster, and after this, I think we can discuss what are potential solutions to this problem. But maybe we can go next. Maybe how about you, Deena? I mean, do you have some experience with like projects gone wrong, or like what are common issues you see in data project management?
So usually part of our job is, or part of the challenge of our projects is that lots of the things we don't know in advance. So for example, Misha has just explained that you don't know what will be in the data, you don't know the test set, and a big part of the successful or lack of success in this project management is how we manage these uncertainties. These uncertainties can be in the tasks, of course, and one of the things that I've learned through the failures and successes afterwards and what didn't work and then how to make it work was to make the task as concrete as possible. Because if, for me, for example, 10 years ago, if I would get the data, I would just focus on the data regardless of the business problem. But with proper project management, usually the business problem comes into the core of the solution and what we're developing and all of our work. So having those concrete tasks or the lack of concrete tasks, this is something that usually causes either a successful project or failing project. And one of the things that Misha has mentioned also, the lack of MVPs. So lots of the projects that did not work that well was basically, as exactly Misha was saying, that we want something which is super state of the art, 200,000 in one shot, nothing in between. We just want to test it. And then it fails as a big bulk. But what I've often seen as a good solution for that, so successful projects, on the other hand, from my experience, do not work as we want a single big thing at the end. But let's start with something which is very minimal. We're aiming for 70% accuracy. That's the top we're aiming for. We develop a very simple model, something like logistic regression, the most simple baseline model. Let's test the whole workflow from the beginning and the end, and then the problems will pop. Because, for example, sometimes we see, again, building on Misha's story, if it would have been a smaller MVP, then probably we would have seen very early on that, by the way, the testing does not match exactly the training data. So regardless of how well the model does perform on the training data, we will not get a good result at the end.
Exactly.
So this kind, sometimes it's called the silver bullet. So just starting from the very beginning, ending with the very end, regardless of how good the details are. So it's not a perfect software, it's not a perfect model, it's not perfect data pipelines, nothing is perfect in there. Just seeing a rough estimation of what we're gonna build. This is something that led to projects failing when it was not there. So the big boom at the end, that's all of a sudden we'll have a perfect product to be used. But projects that have been successful did not do that. It just did a very simple model, just a regression. Let's run from beginning to end. Let's see where the problems are, and let's further improve.
Okay, excellent. Okay, these are, I think, very important points. I think maybe I can summarize, like we should start small, we should have very specific requirements, and we should do things end to end. I think some of those topics we'll cover in a bit as well. But maybe Igor, maybe you can share some war stories about project management in data.
Well, I think I've signed one NDA too many to tell very specific horror stories.
Yeah.
But I think the main reason I've seen data projects fail almost all had absolutely nothing to do with the quality of the underlying data science.
Yeah. Okay.
It's the data science is the cherry on the cake, if you wish. But if you don't have the cake, there is no point in having the cherry.
Yeah.
And so almost always the challenge. So data science projects, they live and die with the underlying IT infrastructure. And if you don't have either the resources or the organizational will to put that IT infrastructure into place and to shape it to the needs of the data science project, then there is no point in doing the modeling.
Yeah.
And that was the main reason for failure, that people were happy to hire data scientists and pay them and even give them access to the data, but they didn't understand that for every data scientist, for every person that does data science directly, however you call them, you need two people, you need twice as much time being spent on the underlying infrastructure.
Yeah.
It can be done by the same person, can be done by a different person, but modeling is just a tiny part of what it takes to succeed.
Exactly. So that's, I think, a very, very good point, that sometimes people think that actually the data science is the complex, very specialized. It is a very hard thing to do, but of course, it's not enough to hire the data scientists and tell them, give them data, give them nice salaries, and then everything will be fine. You realize that you have a pile of other things that you need to do. And this is the IT infrastructure, this is the support from the organization, all of those things, which are actually much harder to change, I would say. Maybe we can go with Filippo now. Like, do you have some stories you can share about project management, data, good or bad? I mean, maybe something nice you can say.
I'll prefer share the good ones.
Okay.
That would be maybe better. Quick disclaimer, I will also be speaking about my own views, of course. This is more personal.
For all of us, I think it's true. Exactly.
Exactly, related to my own experience. I think that, so I really like about a couple of points that I heard, because I think that they are crucial to what we're talking about here. One of the challenges that I see that you mentioned in what you've shown before is that actually one of the principles that we also have in project management in general, for every project, that at the beginning you have the highest risk because you don't have a lot of knowledge about the process, and you will discover these elements along the way. Sometimes with experience you can forecast many, but you cannot cover them all at the beginning. So that's I think that this brings to one crucial point, that is the communication. So in my opinion, what I've seen in general is that when there is no communication, then there's where you have the majority of issues in data projects. Because when in other projects, sometimes the communication could be more natural, I feel like data, especially data science, is somehow more prone to be siloed. Especially the mindset of people working there, especially the complexity of the digital requirements that we have there. Many managers are not yet fully aware of all the multifaceted problems that we can have around the data. And this is often because many managers are not data scientists to start with.
Yeah.
So the challenges could be seen too late. And not because the manager didn't know the existence only, but because also data scientists didn't think about mentioning it, like it was for the case of the multi-class classification. Maybe customers didn't even know what is multi-class. For them, it's somehow normal. We just need different classes, and what's the problem? And instead, it's something that is crucial for many. And I liked what Deena said, because at least what helped me in many cases when I had faced strict deadlines with little communication, it was that actually was bringing delays, was the one that I called the here it is method. Okay. It's somehow like the MVP that you mentioned before, but it's more fine-grained, more very, very simple. At each step of the chain, use the here it is, your data. Here it is, your MVP. Here it is, your minimal step that you want to convey, way before the deadline.
Yeah.
It won't be good, but it won't be perfect anyway in 2 weeks, in 3 weeks, in 4 weeks. There's always time to make it perfect, and it's infinite time.
Yeah.
And as soon as you have this, even at the lowest level, then you will find out what are at least many of the issues maybe you didn't think about at the beginning. Very simple, starting with, okay, here it is, your model, but it's an empty zip file. Okay, do you like the zip file, or you want another format? This model is 2-class classification. Even if it doesn't classify at all, because it's just random, at least you will find out that the final interface accepts 3 classes.
Exactly. I really like where this is going, because it's something I also personally thought about. Like this idea that you should do these things end to end quickly. You iterate then on top of that. I think we have one question. I think 2 questions already. I think one was already answered, but we have one question about how to manage uncertainty during this end-to-end project. I mean, the purpose behind the end-to-end project is to manage uncertainty, I would say, that you kind of start going. And from my personal experience, you have a really complex data science task, and then you can even have this paralysis by analysis, right? You spend a lot of time thinking, do I do this and that? Maybe you should just start from somewhere, try to build something, and then it becomes clear, right? But I think, maybe I can paraphrase this question a little bit. How do we, if somebody, let's say, comes with clear requirements, and we know what to do. How do we start? Like literally, how do we start data science project management well?
Well, I would tend to say that it actually often helps to turn the question on its head.
Okay.
So if somebody comes to you with a precise set of requirements, the first thing you can ask is, let's suppose you had a model that does this. What would you do with it? Would you be able to actually use it if I give it to you right now? And then you first make sure that the harness for actually plugging it in is built. And that usually is slower, takes more effort, is more expensive than the model itself. And once that is in place, you can hack a easy model in a couple of days and then iterate.
Yeah.
But it's usually the stuff around the model that's by far the slower and more expensive.
Exactly. Filippo, I think you also had like a...
Yeah, I totally agree on what Igor said. Actually, I think that if just on top of that, at least from experience, if we already managed to get to the model part, we made a big step. Like 80% of what I've seen until now relies on the data itself, which is even a problem per se, right? So it's another problem within the problem. And one of the customer values is to have the product as they wanted, no? And the customer value is to deliver it on time and on spot. What I like is that you will never remove uncertainty. You need to somehow accept and embrace a part of it. But I really like one of the leadership principles from Amazon, the bias for action. So what we should not do is stay with the doubt and not do anything. It's like if you are, I don't know, in danger and you stay where you are. Maybe you should move and go away from the danger in the first place. And if you take a calculated risk on what you're doing, then probably you're going to end up in a better situation, and you're trying to at least resolve partially. And as Igor said, then iterate from there.
Exactly. I think, Misha, did you have something also to add, or?
Yeah, so I have a slight disagreement with this. I think it's applicable in many situations, what Igor said and Filip then also confirmed. But there are some situations where it's not worth making the whole thing surrounding the model. If it may well turn out that there is no model satisfying your task.
Yeah.
So if you're working on something really challenging, and in the beginning you might not know at all whether it will work or not, then I would say you should start creating some kind of POC that just proves that whatever you're trying to solve is possible, if it is indeed in the customer's interest. Because then the customer can save all the money and effort of building up the integration and the proper evaluation first, because it might turn out to be unnecessary, because whatever the task is impossible.
Exactly. I think this is a great point, and this is the point which will move on to the next topic that we have, because the next topic really relates to that one. So how do we estimate the unestimable, the thing which we cannot estimate actually? So we have always been there, I would say. Like somebody comes to us, says, yeah, let's have a churn model. I mean, actually, maybe that's an easy example, but let's take it. Let's have a churn model, and then you as a data manager, team lead, head of data, whatever, your job is to tell them when this is going to happen. And this is a very uncomfortable thing, because I think what Misha just said is sometimes true. You have to say it might actually not happen. And this is, I think, where you start to see those differences from software, like more traditional software, where you have like back-end, front-end work, to data-related things. This randomness in what we build. And sometimes we just don't know if the data is not ready. It doesn't, I mean, if there is no information in the data to make a model, there won't be a model. And I would like to ask, maybe Deena, you could tell us perhaps how would you approach this? Let's say you have this task at your hand to have. Oh, she just now disappeared, I think. But maybe somebody else can say that. How do you estimate something which you just can't estimate? What are tips and tricks to do that? It's a very hard question, I understand.
I mean, you literally ask how to estimate something that you cannot estimate.
I know, I understand, but we have to, like, we have to say something. We can't just say, yeah, sorry, I can't tell you when it's going to happen, right?
But I think it's very important to know when you can when you can reasonably make an estimate and when you cannot. That's a very good first step. So if you're a manager and you go to the best expert and your expert says, I have not the slightest idea, it might work, it might not work, and then maybe you should just embrace this uncertainty, because instead of trying to lie to yourself that it's not there. Even when we can make estimates, the estimates are typically wrong, right? But there are situations where you literally cannot make an estimate, and then you should know whether it's worth enough for you to invest time and budget and effort, whether such an uncertainty is a no go for you.
Exactly. Maybe a tip there is like what I would sometimes do is I would attach a probability to the estimate. I would say there's like 40% chance that we're not going to have a model. There's like, you could kind of make these confidence intervals from nowhere and comfort the other managers or the senior management. But maybe Deena, do you have experience with perhaps estimating more complex data work? Like, how do you plan ahead in your projects? Like, how do you do your kind of maybe 2 months in advance planning? How do you go about it?
So usually I try to take it one step at a time. And usually at the beginning, I try to take it as well a bit pessimistically. So not in the best case scenarios, but in the worst case scenarios. So at the beginning of every project, I usually try to list all the things that could go wrong in a project. I know it's a bit sad and dark, but it's what helps me, because then I know what to make sure I account for. And as much as possible, I would not get any additional surprises afterwards. And usually the uncertainties build on each other. So for example, if we would receive the data, that's an uncertain thing. But if the data quality is good enough, that's an uncertain thing. If a model would fit this data quality, then that's also an uncertain thing. And we keep on going. What we try to do is sort of just focus on an intermediate deliverable and to say, okay, we are doing the data quality. And once we get this uncertainty done, or clarified in better terms, usually the other uncertainties decreases. So for example, we have good data with good quality, then the probability of the model being built is high afterwards. And it goes on and on and on. So for me, usually it works one step at a time. And overall risk, so usually in a project that I know nothing about, I don't know if the data is there, the business process, anything, I usually go to the customer with a 50-50 estimate, which is usually the rough estimate if we know nothing. But once we go through the process and once we go through the actual data, then it's clear to say, okay, then we have good data, then instead of the 50-50, we might be on 70-30. Or so on. So that's the way I usually try to quantify the uncertainties.
Okay. I mean, like maybe there's the thing, related question I see about techniques, and this is another topic which I want to ask what you think. So, and maybe just phrase it bluntly: does Agile work in data science? And that's the $1 million question. I think Filip is smiling, and because he's smiling, I'll ask him first what he thinks. Sorry.
I feel like an outlier sometimes about this, because it's like I feel less alone hearing that, okay, impossible projects are not just in my field sometimes, but I rarely been asked for something that was straightly possible, because otherwise it would not have been in our field. And this is actually good because it's challenging, and at the same time you want to try it. Maybe you will discover something new. But you will never have the certainty anyway. So to estimate the certainty, you can only base on the past, like predict the future. The best is to use the past. But if it has not been done so far, what can we do? So that's probably just food for thought for continuing the other topic. But regarding Agile, I'm tempted to say 50-50 because it's for data or data science. Sometimes the two things got merged together and they're very different. So that's my first thing, my first thought. And I think that using Agile for data science is like driving a truck, like you drive a car. For sure, there are some similar things, but you see the size of the problem is very different. You can drive data science team exactly like a software engineering team. For sure, there are some things that will work because stand-ups, for example, are definitely helpful in my opinion. Kanban and other ticketing system can also help in some parts. But as the other people already mentioned, sometimes things are not just forecastable. It's not like a software that you know where to start, where to begin. There are some technologies, there are some delays, and that's it. Data science, you're actually making the data speak. And sometimes the data is telling you something that people didn't actually think about or didn't want to hear as a customer. So sometimes you just cannot forecast that. And Agile on that is very useful because you should react quickly. However, the projects that have been done and the milestones, in my opinion, sometimes are not really agile by themselves. You cannot just go to a customer and say, look, we're agile, we're delivering in 3 sprints from now. Sometimes it works, sometimes it doesn't. So it doesn't really depend on the methodology, the agile per se. It's probably a match between different components.
Exactly. Yeah. I mean, I completely agree with some of those points, I think. But maybe does anybody else want to comment on this, like agile data science? Is there a future for this, or should we think about something else? I personally have researched this a lot, and I don't have a good answer. To me, agility or agile is a bit like democracy. Maybe it's not great, but it's the best we have, you know. So this is how I feel about it somehow. Maybe it's a good analogy, maybe a bad one, but maybe somebody can tell me, like, do you do the stand-ups, retrospectives, literally Jira for real data science work? I think if we, let's say what Filip said, let's separate data from data science. Let's talk about data science and machine learning specifically on this question.
I think it's important to separate the communication aspect from the planning aspect. I think most of those techniques absolutely work great for communication. Specifically, Jira is great for communication both inside a team and to other stakeholders. On the other hand, for planning, one has to be very careful to balance longer-term foundational work with tactical work. Yeah. And for tactical work, Agile is great. But if you only do tactical work, then you end up like one of my favorite cartoons that I just chatted where at the end you cannot even do tactical work just because your foundations are something like that.
Yeah.
And for this, you just have to have the courage to resist deadlines and to build things right, at least sometimes.
Exactly. And there's a common criticism on agility is that it can generate a lot of noise, because you can often mistake it for productivity. Like people, when you have a team of 3 to 4 people, you can generate a ton of things. You can literally create a ticket, change the format to CSV. I mean, it really depends what actually you're doing, and not just putting it there and creating this machine of information. A question that we have in the chat, fail fast to learn fast. And I would like to open a controversial discussion here about something which I have observed, especially in Germany, and I think in Europe as compared to the US is often something which I call Pylotitis. So this is the disease of doing pilot projects. And I wonder what everybody here thinks about the balance. Obviously, we do need to do MVPs. We do need to do end-to-end quick. But what happens when we end up with 3, 4 pilot projects which got somewhere, some of them even successful, and only then we realize certain things? Because all of those McKinsey stats that you have very little adoption of machine learning projects in the industry. A lot of money is spent on data scientists, but nothing gets deployed. And this is the dirty secret of data science. I mean, I'm not sure when I made my first deployment. It took a while in my career to make my first deployment as a data scientist. And so what do you think about pilot projects? And I'm interested in the dangerous part of them and how to balance them with long-term thinking. I think it connects to what Igor also said.
I think one is go on.
Oh, good. Okay, I'll make a quick one. Then I'll go into a very slight rant here, but I think one of the general challenges in data projects is connected to the fact that somehow somehow data science projects are not always perceived as software projects. Like, I think software, for me, software is like 95% of even of an extremely challenging project. If it's not a very challenging project, it might be 98% of it. But then again, the people who are working it, the data scientists, they come from all kinds of backgrounds, very often not a solid software engineering background.
Yeah.
So you might end up with a pilot project which like was successful from the data science perspective, but is in such a state that you have to throw it away instead of putting it into production. I believe this is one of the reasons why stuff fails. And if you were like, this question doesn't even really arise in software projects, right? If you have a pilot project in Java and you wrote an application, usually it will not die if it does the job that it was required to do. But with data science, like if you produced a horrible mess out of notebooks and whatever the hell you did there, simply because maybe nobody taught you to do it otherwise, and nobody even expected something else from you. Then they say, oh, this is a success. They give it to the production team, and the production team has eyes like this. I do not think that good software is contradictory to good data science. I actually think that good software is extremely helpful in doing good data science, but I think it's a skill that is kind of missing in the market. So if you were to like flourish with this skill together, I don't think you would have been in the situation where like pilot projects fail so dramatically. So that's my idea. That it's just, if you were to think of it as 90% software, the situation would be different.
It's interesting. It's a very unique thought. I don't think I've heard it before. Like we just assume it's not software, and then we judge it by a different standard. Well, we should judge it by the same standard and address the root cause, not think why do those projects fail. Okay, but maybe I would like to continue perhaps this into another direction. Is like, how do we make sure that we handle expectations in data projects? I think this might be also a source of concern. Like, how do we, like, you have these big expectations, and that's another reason why data project managing can be a bit stressful, perhaps. And maybe Deena, how do you have opinions on this? Like how to manage expectations in data projects? I think the connection is a bit bad, yeah.
I think, well, it's from product management, but the acceptance criteria is one sort of a crucial part to have expectation. Because once we start to, because I'm having a bit of a lagging internet.
Yeah.
Can you hear me?
Yeah, we can hear you, but it's like a bit delayed, yeah.
Okay. Okay, that's good. We're partly there. But I think acceptance criteria, because once we get started and once we communicate and once we set the expectations that, for example, to have this model accepted, then we are expecting this model to do such and such, or we are expecting an accuracy of that much. I think acceptance criteria and quantifying those is a very crucial part of expectation management, because we would not simply get an expectation that everything would be solved by a model, but rather something which is concrete. What exactly are we expecting? This can be done and should be done, of course, with the customer, because during these conversations, we discover lots of different thinking in between us, which is expected. So we do data science, but the customer is more from a business domain, which can be different, in which lots of times causes as well some miscommunication. And having those discussions about what you're expecting, is this realistic or not, and what we can offer, oftentimes actually solves half of the problem just by having this conversation. So this is something that usually helps very much to quantify the expectations and put them in a sort of a document that this is what we are going to build and this is what you're expecting.
Yeah. So maybe I can connect this point to something that Igor said a bit earlier, is that you can turn some of those projects around and say, okay, imagine your model is done. So what do we do? Like, are you happy with this? What do we do after that? I think this is something that often happens. I call it the so what problem, right? So we spent all this money, all this effort to create a model, to deploy it. But only then it's realized that, yeah, but what do we do? And often my experience is often you start to get like more questions about the validity of this model, even if what you report is great. And how does it fit with the existing architecture? I think this is also something very dangerous that often happens at the end of a data science project. What do we do now?
Maybe to add one comment to that we had, for example, in one of the companies, we did have the problem that we were working for internal customers, and oftentimes they would like to understand what's in the data, see what's the possibility, but then it was painful, and I can understand that, to change the business process to actually fit in the model. Because if we're saying that we will put the model into production, it will get used by your users, employees, team, whoever the user is. That means that a part of their business process and daily change will be changed. And this is something that we need to account as well, that our job has a sort of a change management component. So it's not just the software, but there's lots of humans and people in the center, and this is something that we need to account for. But as well to hold them responsible, that if we build something, if we meet the acceptance criteria, then you will have the responsibility of this change management. So if this happens, if we do meet this acceptance criteria, then it's your responsibility to change the business process to integrate the model.
Exactly.
Oftentimes when the...
Yeah, but maybe for the interest of time, I would like to move maybe to one of our last topics and I will try to put it together into one about rigidity in project management for data teams. We balance, let's agree that we have to do Agile for the time being. Let's say some version of that we need to do. So how do we make sure that we don't overdo certain things? I can give a specific example. When we literally have like everything should be perfectly defined. We should always try documentation. So obviously those things, you have this balance, like you do things for the midterm, but you want to be productive quickly. People want to experiment, but you want to document their results. And maybe I can provide a quick answer from my side to one thing, something which I found interesting in improving data science project management was treating it as a science. So when I was working in bioinformatics and in biology in general, we worked in a lab often. I was personally often on a computer, but my colleagues were doing experiments. And we had this physical laboratory notebook. It was literally like a normal notebook, but it was like done in such a way that you can't manipulate it easily. And we had to record the results of our experiments all the time. And this actually even served as a legal document, because your scientific results, they're funded by the government, and this is proper work. So I was thinking of one thing which I try to implement in my teams is let's actually have that, let's use Confluence. You hate it or like it, this is what we're going to use, and let's document our data science experiments results, the bad ones, the good ones, the exploratory data analysis, the model performance, we say on which subset of data it is trained, all of those things. So this, from my perspective, is something that worked, and it wasn't too rigid. But maybe do we have a comments on how do we as managers introduce bureaucracy in a constrained way without being inefficient? So maybe, Filip, we're smiling again, maybe again, why don't you go now with this one? And we can make a round, and then I think we can go into questions.
Yeah, I'm actually smiling because you're touching very interesting points that I'm questioning myself from time to time still, I will not mention any tool in particular, not to make advertisement, but fortunately today, compared to what we had 10 years ago, we have a lot of tools that can automatically, for you, at least alleviate some part of the problem, like machine learning model versioning, data versioning, pipelines versioning, so that you can compare the results without doing all that manual work, which will probably kill some of the data scientists you're working with. Not because they are not capable of doing it, but because they're passionate about something else. If in other cases you have someone in your team which is passionate about that, then probably the synergy among the people will be your best tool. At least from my experience, what I've seen works well is that when you have someone that is passionate about maybe perfectioning a model and someone else that is passionate about making the software engineer or the DevOps behind that, or the documentation, or you can exchange this with any element you have in your project, and when they can work together in synergy, so that the one that wants to make the model can make a fast version of the model and then pass it to the other one, which will make the deployment or the documentation and everything that you may then learn one from the other. And someone will probably push on one side, someone will push on the other one, and together they'll go right straight ahead. But there is no magic one for that situation, because there will be some constraints that must be respected, that business wants, and the only thing you can do is knowing when to stop. You can always make better things here and there, but they will eat all of your time. Well, you could implement better things on the other hand, so you could use that time more efficiently on others.
Exactly. I love the idea that you say that actually we try to treat it as a mechanical problem, but it's a people's problem often, that we actually need to take care that the people, their personalities, their skill sets, their people are diverse, they're not interchangeable, exchangeable data scientists. Even if you share the same title, you might do things differently, right? So we should pay attention to that. Some people might be more interested in the organizational aspect, while somebody wants to go further and break things. I think we just have 4 minutes, so which means I would like to address at least one question. And the question is from Javier, and this is about about product discovery. How is that different in a data product in comparison to a normal one? So I would say this is kind of the ideation phase. How do we how do we start even data products? Where do those ideas come from? I mean, do we have some thoughts? I mean, I know he asks for book recommendation, but does anybody have an answer to how to approach the start? How do we decide what to do? The big idea, where does it come from?
I actually have a very interesting story about that, because one of my projects came from a job posting. So to understand what's happening, It was a medium-sized organization, and to understand what's happening as well, of course, it's not easy to catch up with everything. So every one time a week or something, I spend just 10 minutes to see the job postings that we have as a company. And one of the job postings was about workforce management. So one of the customer service was looking for a workforce manager to manage the incoming tickets, how many people are there, and so on. Once there is a business need, and once we have the mentality as data scientists to actually understand what people needs, I think there will be lots and lots and lots of opportunities to dive deeper. So that was one source to what do the people do? How is it needed? The job posting. So how is the organization developing? How can we help in that? By the way, we actually proposed this project. It got accepted. It is currently, I think, so I left before it got finished, but I already developed the first phase of the project. So, and that's the thing, that we're not just working in void, but rather we're addressing pain points of the actual customer. Of course, he was very happy to take the project in and to deploy it and to use it. And it was one of the best projects that I've ever had, actually.
Exactly. Yeah. Igor, go ahead.
Yeah, Deena, I think that's key what you're saying, reaching out, understanding those needs. In fact, I think the best way to have an effective data science team is have certainly the senior data scientists be actually hybrid, either hybrid product or hybrid DevOps, and not just pure data scientists. Because this way you don't have an external client that you're dealing with, and therefore the need. I think that's much better way of, for example, of crystallizing requirements than having somebody write them down for you, is to be that product person, to have the product person as part of the team. But the challenge, yeah, I agree with Deena completely. The problems are everywhere. So the challenge is not what could we do. The challenge is which one's actually worth doing.
Okay. So we have just 1 minute. So I know that there's more questions coming up. So about the questions, I would say, please reach out to all of us. I think all of us have a LinkedIn profile, so please reach out, ask anybody about those questions. I think all of us can answer them well. For my just a closing thought from me, it was just a pleasure to talk to all of you. I learned a few things. I mean, I have a high opinion about what I know, but still I learned so much from all of you, and it's so nice to share those stories. For me personally, I learned things from this talk. I hope everybody who was around also. And yeah, from my end, I think this was great. And maybe Laura, do you have some final words?
Yeah, absolutely. Thank you so much, everyone. I hope everyone enjoyed the panel session today. We will have some more panel sessions and keynote speeches coming up with the AI series in the coming months. We are just finalising some topics, but we will have an event calendar put together shortly on our website. If you do have any questions, any feedback, or you'd want to be involved in one of the AI series in the future, just click the links that I've put in the chat and contact me, or contact one of our consultants via the Oxygen Digital site. And of course, if you're looking for your next step or your next move, or perhaps you're looking to grow your AI or data science team, just get in touch with us and we will help you the best way we can. But thank you very much, everyone. And I think this has been an incredible discussion. We'll have the live recording sent through via email. But if you do have any questions, anything further, then please don't hesitate to get in touch and email me. But
All right.
thanks very much, everyone. Take care.
Have a nice evening.
Thank you.
Bye-bye.
Bye-bye.
Thank you, everyone.
Thank you.
Bye.
Bye.